So far we have done all the basic techniques and tools for solving indefinite integral. Okay. Now let us see some more complicated situations where we are required to use our skills to get rid of indefinite integral and find out what is the antiderivative of given function. So evaluate percentage किती आहे 60. Okay, evaluate integral I is equal to e raised to ax cos bx dx. Yesterday we have seen when you have e raised to x function along with u, it is very useful as far as integration by parts is concerned. So now try to find out what should be the formula for this. So this is not example, this is formula to be remembered. Try to do it. Applying integration by parts where e raised to ax we are considering u first function. Even if LIATE says we should consider exponential function as second, here we are considering as first because after 2 times integrating cos we go back to cos. Okay, and therefore this is v, and hence your I becomes, applying integration by part, u into integral of v. So e raised to ax integral of cos bx is sin upon b minus integral sin bx upon b, that is integral of v into derivative of u is a raised to ax dx, right? Therefore you get e raised to ax sin bx upon b minus the constant is a by b integral e raised to ax sin bx dx, right? Now again we apply integration by part to the second part here, a by b inside bracket u into integral of v, that is minus cos bx upon b minus integral of cos bx upon b, that is integral of v into derivative of u a raised to x dx. Now let me get rid of this square bracket. E raised to ax sin bx whole upon b. Now this minus sign makes it plus a upon b square e raised to ax cos bx. Then again this minus sign makes it plus a square upon b square, and then you have integral e raised to ax cos bx, which is I, right? So this is also I, and hence now what we can do is we can take this RHS I to the LHS and 1 minus a square upon b square, which is बरोबर चाललंय ना, b square minus a square upon b square times I is equal to इथे साइन चुकले का माझं?
In the integral,
This should be minus.
sir.
integral of sine bx is minus cos bx, and hence the sign here will be negative, and it goes to RHS, becomes a square plus b square times I is equal to, now if we take the denominator equal to b square and e x common, then inside bracket b sine bx plus a cos bx. Okay, and therefore I is equal to, if you multiply this to this side, e raised to x upon a square plus b square, inside bracket the first term we should write a cos bx plus b sine bx. This is one way of expressing your integral. Okay, now because this angle is same both places, we can club it using trigonometric formulae, and we can say that this is also equal to, this is also equal to e raised to x divided by radical a square plus b square times cos bx minus tan inverse b by a. Okay, dividing both sides by a square plus b square already there, so you consider a upon a square plus b square as cos alpha, b upon a square plus b square as sin alpha, and you can combine these two. I mean, you have to take radical inside. Check whether you understand from here to here, otherwise I will write couple of steps in between. So these are the two expressions for the given integral I. Okay, so if this is done, then we should find out the formula for integral e raised to x sin bx dx. Do it in few minutes. Okay, the answer for this is going to be similar. E raised to x upon a square plus b square. You write down the first term, this a sin bx, and minus b cos bx. That is how you are supposed to remember. These are the key points where you should note that if plus minus, then you will make mistake. And the second formula is almost similar, e raised to ax upon radical a square plus b square sine bx minus tan inverse b by a. Right? So these are the two formulae. Again, you have to remember. Now, 4 years before, when I was talking to students between mains and advanced, they had, at that time it was only one mains and followed by advance, and we had some discussions in between. When I was checking with them, some advanced problem I was trying to solve in class, and majority of them, including toppers, were not aware of this formula, ready-made formula. I mean, given a time they would derive it, but having given mains exam, every individual must remember these standard results. Then only you will be able to save time. If you believe in yourself and say that no, I can derive at any moment, therefore I need not remember, then you are not in race of IIT. You have to remember these because speed is important and these standard results are to be remembered. If it was Olympiad type, different long answer type exam, then fair enough. You need not have to remember, you can derive it. You have plenty of time there. But if it is IIT type of exam, not only the standard results, but some standard problems and their solutions are also required to be remembered. Then and then only you will arrive at the final answer very quickly. So that was my observation in the class, that in spite of saying that this is a standard result, standard formula, many of you students at that time were not remembering. And if you keep solving problems using this formula, then only you will remember them. त्यामुळे काही गोष्टी या लक्षात ठेवायलाच हव्यात. तिथे आपली हुशारी आड आणायची नाहीये. आपण हुशार आहे, आपण डिराईव्ह करू शकतो, पण म्हणून ऑन द स्पॉट मी डिराईव्ह करू शकतो, ठीक आहे, पण द टाइम that you are giving is not allowing you to do that. Okay, I am recording, so might as well I go to the next problem. The problem number is, किती झालाय? 70 झाला ना? 71. Problem number 71. Percentage 56. E71. Integral cos log x dx is equal. Show me the answer. Half x or x by 2 inside bracket sin log x. White board la. Sin log x plus cos log x E71. Integral e raised to 3x sin 4x cos 5x dx. Answer for this problem is 1 upon 16 e raised to 3x inside bracket sin 9x minus 3 cos 9x minus 1 upon 20 e raised to 3x inside bracket 3 sin x minus cos x. Okay. If anybody wants me to write down the detailed solution, I can do that. But I think it is easy. The only problem is to separate these two guys and solve two different problems. Solve means apply formula. E72 integral a raised to x cos x dx is equal to. Yes.
You wrote 71 twice. This is actually 73.
Oh, 71 twice. So this is 72. This is 73. Stop recording. Okay, as far as 73 problem is concerned, you substitute a raised to x, get into log to the base e form and put that everything back into this integral. You will get it in standard form, and then applying formula you will get the final answer as e raised to x log a upon log a square plus 1 log a times cos a plus sin x. 74th problem, integral e raised to tan inverse x upon 1 plus x square bracket square dx is equal to, find out. Okay, so you have to match your answer with this answer, e raised to tan inverse x upon 2 plus e raised to tan inverse x upon 10 inside bracket cos tan inverse x plus 2 sine 2 tan inverse x bracket complete plus. Try to match your answer with this. Okay, I will just write down the solution quickly. Put tan inverse x is equal to t, guys. 1 upon 1 plus x square dx is equal to dt. That implies, now if tan inverse x is t, then x is equal to tan t. So 1 plus tan square t is equal to sec square t. So 1 plus x square, so dx is equal to 1 plus x square means 1 plus tan square t is equal to sec square t. So dx is equal to sec square t dt. Is that right? बरोबर आहे. So in the given problem will become e raised to t and okay, I need not have to do this because anyway I have dx upon 1 plus x square with me dt. So dx upon one of them is dt and one more of them is sec square t. Okay, this will be integral e raised to t cos square t dt, which is integral e raised to t cos square t is 1 plus cos 2t upon 2, correct? And therefore you have two problems. One problem is half integral e raised to t dt and other problem is half integral e raised to t cos 2t dt. This is simple. This is e raised to t upon 2 plus half. We have to apply formula. Here a is 1 and b is 2. So e raised to t upon radical 1 square plus 2 square, that is 5. Not radical, a square plus b square. Insert a times cos bt, that means cos 2t plus 2 sine 2t. Replacing inverse x, you get the desired answer. शार्दूल, अरे शार्दूल साठी चाललं होतं आणि तो बाहेर गेला. Next problem. Okay, so this is one particular type of questions. If you are supported by e raised to x, you should deal with them like this. Formula, evaluate integral radical a square minus x square. Now, these are the few more algebraic integrals which are similar to the 6 integrals that we had written few lectures before. Then these are also to be remembered along with them because they are similar and you will get confused. So first of all, derive how much is this? Okay, as this is a formula, the final answer need to be remembered, and again it is type of I appearing in RHS again. If you keep working on it, applying integration by parts 2 times, I will, this is I, will appear in RHS also, and then if you do the algebraic simplification, you get this answer. Next, evaluate. Again, you are supposed to assume second function as 1. Therefore, you get x radical x square plus a square u into integration of v minus integral of v, that is x, into derivative of u, which is 2x denominator 2 radical x square plus a square into x dx. Okay, that is derivative of radical. So x radical x square plus a square minus 2 gets cancelled. You get integral x square upon radical x square plus a square dx. Now the challenge is to solve this integral. So we break it in parts. X square plus a square upon radical x square plus a square dx minus integral minus minus plus integral a square upon radical x square plus a square dx. Correct? So this is standard, which is equal to x radical x square plus a square minus integral radical x square plus a square, which is same as I, plus this is our standard formula, a square. What is the standard formula for that? Log x plus radical x square plus a square, right? Let's see. Now this integral is I, which goes to the other side, becomes 2I. Therefore I is equal to x by 2 radical x square plus a square plus a square by 2 log x plus radical x square plus a square plus this is what is your formula and need to be remembered. And the third in this series is evaluate integral I is equal to integral radical x square minus a square. Find out what is the difference in this and earlier. And okay, the only difference in this and above is this minus sign in between. Otherwise, radical comes here exactly same as given. Radical comes here exactly same as given. Now, having learnt this, what is the next number? 70. Problem number 75. Problem number 75. Sorry. E75. Easy problems first. Integral radical 3 minus 2x square dx is equal to. Para application of formulae, therefore answer is x by 2. E76 integral x radical x fourth minus a fourth dx is equal. Okay, solve this. So the answer for this, what is the substitution? X dx is waiting for you. Therefore, of course, the substitution will be x square is equal to t. Right? So if we put x square is equal to t, we get 2x dx is equal to dt. And the integral becomes radical t square minus a square dt of half. Correct? And this is our standard formula. Therefore, the answer is 1 by 4 inside bracket x square radical x fourth minus a fourth minus a raised to 4 log x square plus radical x fourth minus a fourth bracket complete plus, okay, E77 I is equal to integral radical x square minus 2x plus 5 dx is equal to. Well, the answer is x minus 1 to radical x square minus 2x plus 5 plus 2 log side bracket x minus 1 plus radical x square minus 2x plus 5. Plus simple. E78 I is equal to integral x plus 1 radical 5 plus 4x minus x square dx is equal to. Okay, the trick here is, I mean, this x plus 1 is a burden right now. If it would have been radical 5 plus 4x minus x square without this term, then it would have been easy. So what should we do? We should adjust x plus 1 in such a way that a times ddx of the quadratic that you have, so that is going to be linear, a times that linear term plus b, and a and b are constant. So this is minus 2x plus 4 times a plus b. Comparing coefficients, we have minus 2a is equal to 1. Therefore, a is equal to minus half. And my 4a plus b is equal to 1. So, how much is this? Minus 2. B is equal to 3. Okay, and therefore the given sum can be written as is equal to integral, instead of x plus 1 I can write minus half times minus 2x plus 4 radical 5 plus 4x minus x square dx, that is first part, plus integral 3, that is b, into radical 5 plus 4x minus x square dx. So we have two integrals to solve. Now this is little easy compared to earlier because this is derivative of something inside. So minus half common inside bracket. If you substitute this radical as t, you have root t, and this is derivative dx, so dt, plus 3 integral. Now method of completing square should solve this. Okay, and this is also solvable now. Therefore final answer is minus 1/3 into 5 plus 4x minus x square raised to 3/2 plus 3/2 times x minus 2 radical 5 plus 4x minus x square. The last term is plus 27/2 sine inverse x minus 2 upon 3 plus c. I hope you have understood this. Now let me give you the next problem. E79. Okay. I don't have answers written with me, but still I can give you. E raised to x radical 4 e raised to 2x minus 5 e raised to x plus 1 dx. Now I need an answer from somebody, therefore solve it carefully. I don't have answer written in my notes. Okay, so answer for this, if you substitute e raised to x is equal to t, you end up getting radical quadratic in t, and which you should solve as a standard problem, and the final answer looks like this. Okay, so that completes yet another part. Now evaluate in is equal to integral sine nth power of sine x dx, where n is positive integer. We need to develop formula for this now. Try your level. Let me start doing it. So if n is given, that n is equal to say 7 or n is equal to 9 or 10, then we should be able to find out the integral quickly. That is the idea of developing the formula or developing the result for n. So in integration by parts, and we consider this integral as integral sine raised to n minus 1 x into sine x dx, u into integral of v, u into v. So first term is this, second term is this, therefore u, that is as it is, sine n minus 1x into integral of v is minus cos x minus integral of v, which is minus cos x, into derivative of u, which is n minus 1, sine n minus 2 x into cos x dx. Correct? This is minus sine n minus 1 x cos x. First term will continue to remain as it is. Now what have you got? Minus sign, so this becomes plus. Cos becomes cos square. N minus 1 is a constant. Integral sine n minus 2x cos square x can be written as 1 minus sine square x dx. Right? Is equal to minus sine raised to n minus 1x cos x plus n minus 1 integral sine n minus 2x dx is into this minus n minus 1 integral what do you get? Sine raised to n x dx, which is same as what is being given to us. So this is I goes to the other side, which becomes 1 plus n minus 1 times I is equal to minus sine n minus 1 cos x, n minus 1x cos x, plus n minus 1 integral I n minus 2. So I have jumped from n to n minus 2. That means I am moving. If this is 10, then I have reached 8. From 8, I can come to 6, 6 to 4, 4 to 2, and then I should be able to write the complete integral. So let me write down one more step, because the coefficient I have to make it 3. I must be 3. So I is equal to, this is what, n. So minus sine n minus 1 x cos x divided by n plus n minus 1 upon n I n minus 2. This is reduction formula. This is called reduction formula. Okay, you express in terms of in minus 2. If I want to express in minus 2 in terms of in minus 4, I have to use exactly same formula again. Okay, so you may think that we have done it at this stage, because if n is a positive integer, n eventually this will reduce to either I0 or I1, which is easy. What is I0? That is integral sine raised to 0 x dx, which is integral dx. And what is I1? Integral sine x dx, which is minus cos x plus c. So both these integrals are easy, I0. Or even if you want to stop at I2, which is integral sine square x dx, we have found out this also. So you can find the answer by stopping at 2. So if n is even, you may stop at I2. If n is odd, you may stop at 1. That is how this type of problems needs to be tackled. Okay, so if we have developed formula for sine raised to n, the job next is to develop it for cos raised to n, or integral do it. Okay, the formula is this. Because it was sine earlier, we ended up having negative sign. Because it is cos, the integral is positive, therefore we have a positive sign for the first term. So evaluate integral sine raised to 6. Let me give the problem number. I just want to check how many. Kitty, what is the next number?
80.
80. Example 80. Integral sine 6x dx. Okay, the answer is minus 1 by 6 cos x minus 1 by 6 cos x sine fifth x minus 5 by 24 cos x sine cube x minus 5 by 16 cos x sine x plus 5 by 16 x plus c. Now, can we really imagine that if we differentiate this RHS, we will get sine raised to 6x, but we will get. Okay. Now I don't have answer, but I have to give you this problem. 81 integral sine fifth x, or yeah, so that you come to know how do you get those integrals quickly. And you are not going to be given the index as 97 or 98. I mean, it should be doable. Okay, so the answer for sine raised to 5 is this. Now there is no point in writing cos raised to 5, etc., because they are going to be similar. So how do you deal with, say, E82 now? Integral tan cube x dx. खड़ा हो गया. Tan cube x dx, the answer is tan square x by 2 minus log sec x plus c. E83 integral cot fourth x dx. Last example. The answer for this question is minus cot cube x upon 3 plus cot x plus x plus c. Okay, that is where we stop for the day.